Hello, my CTO Demon Channel friends. Welcome back to another core curriculum talk. This is the first talk we're going to do on the Global Safety Consensus document. So after the Global CTO Consensus group wrote the Global CTO Crossing Algorithm, we felt the need to write a safety consensus document to go alongside the global algorithm. The global CTO crossing algorithm taught you how to cross the CTO, the methods to use, but we felt safety was very important. So along with a few more extra authors, altogether 147 authors, we formed what is now known as the Global CTO Consensus Group. We wrote the global recommendations for safety in chronic total occlusion intervention paper, which is now awaiting review in journals and I hope to be published soon. Now, I've explained in another video, the first video, on why it's important to have so many authors so that we get a big data set, a big opinion about CTO PCI so that we can decide what safety mechanisms are important and which are not so important. Now, the paper is in 12 sections, and of course I can't cover 12 sections in one video. So this first video is really only going to cover the first two segments, which is the safe setup for CTO PCI and the issues with guiding catheter, part 1. So safe setup. After a lot of emails back and forth between the 147 authors, we decided on what is essential in a cath lab that's going to do CTO PCI and what is optional but preferable. The 6 essential things for safe CTO PCI are an echo machine, because we need to know when we've caused problems with the LV function, and we definitely need to know if we have pericardial effusion and tamponade. Cover stents, coils, and compatible microcatheters for coil delivery. Because perforation happens, we need to be able to deal with those in the cath lab. ACT machines, because checking ACT is considered essential for CTO PCI, and pericardiocentesis set, also essential. These are the 6 essentials that we listed for safe CTO PCI. On the setup, of course, corresponding to these 6 things is a team that's familiar with CTO PCI, with radiation safety, with CPR, because every now and then we need to deliver that, and with pericardiocentesis. What is considered optional, preferable, but not essential is hemodynamic support devices such as ECMO, IBP, or impeller. Now, why did we decide that these mechanical support are optional? Of course, it's very nice to have the availability of impeller to do an impeller supported CTO PCI. But you know which cases are going to need an impeller support. So you have an EF of 15 and you're going to do retrograde, you can refer it to another center where they have support if you don't. It's not essential to have it. And really, I think it's a balance between how easy it is to do, how simple it is, and how effective it is, and what is the chance that this safety thing can have a benefit. So let's go back to vehicular safety first of all. The safety belt, we all agree, is very worthwhile. It's a simple device, not complicated. It's easy to do, you just click it in, okay? And it practically prevents a catastrophic disaster. You falling through the windscreen, rolling on the motorway, and watching the cars behind zipping past you and running you over, okay? Instead, now you're in the seat of the car, maybe with a bruise, okay, granted, but you're in a much better position. So obviously it's worth doing. Now, let's talk about an ejection seat with a parachute for a car. Now, that may come in handy if you crash your car and all the doors in the cars are stuck and you burst your petrol tank and there's a fire in your engine. Okay, if all these things happen, you can't get out of the car, okay, and the car is about to blow up. So you're going to die. You don't have time to wait for the fireman to come and cut you out of the car. So if you had an ejection seat, you can press the ejection seat and you'll be shot up in the air and a parachute will open and your land safety on the motorway. Except there are several problems with this concept. Number one, if you've been in an accident that's bad enough to have damaged all 4 doors of your car, the chances are the ejection seat mechanism has been damaged and it probably doesn't work. Secondly, if you eject yourself up from the ground, you probably don't get enough height to use a parachute safely to land on the ground. And you might do yourself a serious injury. And thirdly, even if you successfully land on the ground, you're on a motorway with oncoming cars dragging a parachute. That's not exactly a safe position to be in. So, we don't put ejection seats in cars because the chance of us needing ejection seats is very low. The chance that all the doors are stuck and the petrol tank is burst and there is a fire on the engine is low. And number two, it's a very complicated and involved mechanism that might not work very well. And number three, even if it works, you're in a terrible position. And the ejection seat to me is exactly like mechanical support devices, especially the more complicated ones. You very rarely need ECMO. Usually it's not one thing that's got wrong. It's not that you failed the CTO or you made a small perforation that's caused the need of an ECMO. Usually multiple things have gone wrong. The doors are all stuck, there's fire in the engine and the petrol tank is burst. Multiple things have gone wrong before you need an ECMO for CTO PCI. And the ECMO is not very effective. It doesn't solve all the problems. You're in a very bad position with very big devices that have bleeding risk stuck in you that may also generate clots. You're not in a good position when you need this. So I think the ECMO and impeller especially is kind of like the ejection seat for the car. And so the global consensus group decided that they were optional, it's good to have them, but not essential. Finally, an X-ray machine with low radiation dose. Of course, this is good for CTO PCI, but again, it's optional, not essential. Because today, if you follow our global algorithm, most of the time you can finish the CTO case before you run out of radiation. So of course, if you have a big lab, like those labs in China with 15, 30 X-ray machines, you can pick and choose your X-ray machine with the lowest radiation dose to do your CTO in. And even if, like me, we only have 2 and soon to have 4, hopefully, Cath labs, you can choose the machine that has lower radiation for your CTO cases, and that's a good idea. But if you don't have it, it's not a disaster. So those are the recommendations for a safe setup for CTO PCI. Now, I have enough time, I think, in this video to also cover guiding catheter. Now, guiding catheter in CTO PCI can have several types of problems. Number one is the embolic problems, and the 2 types of common embolism is air embolism and thrombus embolism. And this is more prevalent in CTO PCI because number one, we use trapping balloons. Number two, that we use multiple devices. Often you have a trapping balloon or you have a side balloon anchor and a microcatheter inside. So many devices in the catheter. And number three, the often use of guide extension catheter. In fact, the more stuff you have in your guiding, the more chance you introduce air and you introduce thrombus in your guiding. So the solution is to back bleed often, okay? But of course, this is easier said than done. The place that really is a problem for us, I think, is when we are using the trapping balloon. Because every time you use a trapping balloon, quite a lot of air gets introduced, and if you inject that air, and bad things happen. So whenever we use a trapping balloon, we must remember to back bleed afterwards. Now, my own experience is that this is not a problem the majority of the time, but even in recent memory, there's 2 cases where we've injected after trapping without back bleeding and caused a problem. And usually it's when something terrible has happened to the case. So we've done something, we've trapped it out, and the patient's losing blood pressure because something else has gone wrong. And we want to see what's happening. Then we forget to back bleed and inject. That's even worse because the blood pressure is already low, now you inject some air in. So it's always a bad. So I think it's always important to remember and almost make it a habit of back bleeding as soon as you finish trapping. Even either remove the trapping balloon and back bleed, or back bleed even if you're not going to remove the trapping balloon. Make it a habit. The second thing is we should keep the ACT high, and the recommendations is 300 for antegrade, 350 for retrograde. And we need to be very careful with the donor vessel, because the donor vessel is where big disasters happen, because the donor retrograde vessel supplies two territories. It supplies the CTO territory as well as its own native territory. And if there's something bad that goes on with the donor vessel, we lose two territories, and usually the patient goes into cardiogenic shock. So the donor vessel, on top of what we said earlier about guiding catheters, we should also aspirate regularly. Because sometimes we leave the donor vessel for quite a long time without doing retrograde injections. So before we do, we should aspirate to get rid of clot. And we should also remove the retrograde guide as soon as is possible. Now, we've left it fake like that in the paper because I think for different operators there's different times. But what I want to avoid is what I see very often in cases is that people have already got antegrade wire access. Maybe they've gone retrograde marker wire or something like that, or maybe it's just a retrograde guide to help inject retrograde to see where the distal lumen is. They got antegrade access and they already ballooned the antegrade. There's no more use for the retrograde guide, because once you balloon the antegrade, the retrograde is not going to fill. So you should remove it. But often you see stenting being done, IVUS being done, post-stent optimization done, and the retrograde guide is still sitting there. So we shouldn't do that. We should remove it. For me, usually, if I've externalized the wire, of course, I can't remove the retrograde guide, and I've got to wait until I've stented and optimized the stent. But if I haven't externalized the wire or changed to an antegrade access, I would remove the retrograde guide as soon as I've ballooned with a reasonable size balloon the CTO vessel, and I know I can get stuff down. So the other problem, apart from the guiding embolism, is guiding dissection. And usually this is at the ostium of the vessel where the guiding tip is. And guiding dissection is more frequent in CTO PCI because we use more aggressive guidings. And also, two other things. Number one is that when we use aggressive guiding on the antegrade side, we put the CTO wire down, and the CTO wire is pressing hard against the CTO body, and it's actually pushing the guiding out. So when we are wiring the CTO body, the antegrade guide doesn't often cause dissection. But when our wire has gone through the CTO body, suddenly there's no more resistance at the tip of the wire. And so the guiding now can deep seed in. And that's also when we start doing harder injections. And so that's a danger point. When your antegrade wires cross the distal true lumen, from that point you need really to pay attention to your antegrade guide, because there's a risk of it deep seeding. The retrograde guide has a similar problem. When we try to remove retrograde gear, the retrograde gear is often very stuck, and when we pull back hard, the retrograde guide deep seeds in, and there's a risk of guiding dissection. So we should back out the retrograde guide or put a cusp wire to prevent retrograde guide dissection. So there is these three mechanisms that cause the problem of antegrade dissection. What are the solutions? Well, first, a cusp wire. So if you put a cusp wire in, the guiding can't seed in, and that's a very good solution, especially for removing retrograde gear. Secondly, sometimes we do osteostenting, especially if the ostium is diseased anyway in the antegrade side of the vessel. We might as well stent the os with a big 4-0 stent, and then we can deep seat the guiding, get better guide support, and our ostium is safe. Side hole guidings. Now, this was debated hotly in the CTO consensus group. Some people argue that side holes don't really prevent guide dissection. You can still dissect the os with a guide in a side hole guide, and sure enough, I'm living proof of that. I've done that many times, okay? And also, side hole gives you a false reassurance because you can't see pressure dampening if you have side holes, and absolutely that is true. But despite that, there's also enough authors on the group to feel that side hole guidance is helpful. Side holes do reduce barrel trauma because some of your contrast is going to go out to the side hole. Side holes do allow some perfusion if the guide is a bit damp, so it is good. So in the end, what we settled on was side hole guide is useful as long as you understand that side hole guide may mask damping, and sidehole guide can still dissect the vessel, and we still need to be careful with sidehole guiding. Finally, the safety wire. Safety wire is very useful because safety wire is kind of like the seatbelt. If you have a safety wire down the vessel and then you do a guide ostium dissection, okay, then you're in a much better position because you can just put an IVUS down, check where it is, or just put a stent down and control the dissection inflow. So you're in a much better position. So it's always good to have a safety wire. Now, when we do CTO, often we already have the baseline angle, so we know where the vessel is. So once you put a guide in, you might as well just put a wire down first before you do any injections. So we highly recommend the safety wire for both the antegrade and the retrograde. There's one special guiding issue with a donor vessel. This doesn't occur in regular PCI because we don't usually put a guiding on the opposite vessel. But in donor vessel, we need to be particularly careful because guiding dissection is dangerous. And in this safety consensus document, we talk especially about ipsilateral retrograde. So if we do ipsilateral retrograde cases, we can either use one guide, single guide method, or we can use ping pong guide. And we highly recommend the use of ping pong guide for several reasons. Number one is that a single guide, when you remove the retrograde gear, and it gets stuck, it's very difficult to back it off because your retrograde gear is very near the hub and you don't have much space to back off the guiding. And when you pull, the guiding will deep seat. Of course, you can put a cuss wire, but you're putting a lot of gear in a single guiding. Secondly, is sometimes when you've externalized and your retrograde microcatheter is back into the same guiding, you cannot pull it back. It gets stuck. Gear entrapment is increased if you have an ipsilateral single guide. If you have two guides, of course, you can use a balloon or something down the other guide to push the retrograde gear out. So you're in a much better position. And finally, a single guiding in ipsilateral collaterals increase the risk of strangulation because if you have both sides and you can't move it back and forth, you end up pulling hard on both sides and strangulating hard, causing cardiogenic shock. So for these reasons, we highly recommend the use of ping pong guides when you're doing ipsilateral retrograde. We also need to do one thing is that when something goes wrong in the case, we should always remember the donor artery. We should always think that the donor artery might be in trouble, and we should have a very low threshold to check the donor artery to make sure it's okay. And we should also have a low threshold to treat the donor artery. So often if there's an intermediate lesion on the donor artery and I need to go retrograde, I'll often stent that first because donor artery thrombosis is very risky, and I've certainly had a few, and I know many retrograde operators have had quite a few donor artery thrombosis cases. And so it's important to treat intermediate lesions in the donor artery before you go through it. So that covers really the first two topics of safety. And I hope you find the video format easier, and I hope the paper comes out soon so you have the actual paper to read it too. I hope you have a safe CTO PCI and successful CTO PCI. If you like the channel, do click the like button. If you want to see the rest of these safety videos, do subscribe so that the new videos that come out, you will know about them. Have safe and good CTO PCI. Bye-bye.